Hello guys. So from today onwards, we'll working on making the system production ready. I have created the demo version which is for development and in-memory usage. Now I'll move towards Redis and use sorted sets, hashes, pubs, all that to make the system production ready. And the code will also be somewhat changed to make it look production ready. So let's start. First thing we'll do is make the queue manager production ready. Uh, the queue manager doesn't need much changes, but some small little bit changes, like having a default queue at start, something like that. The first queue the user creates is always will always be the default queue. Some rules like that, and that's all. So let me start by coding and then I'll explain each and everything while I code. So starting with the manager.go. First thing we need here is a default queue name, which is a string. Okay, so it will be a string which will default queue name. In the new queue manager, nothing needs to be changed. Now you might be wondering that will we use Redis in queue manager? And the answer to this is no. We won't use Redis in queue manager currently. Currently, the queue manager will live in memory, and Redis will work independently on queues and jobs. Later, if we need something to make queue manager irreplaceable, we can use a database for queue manager, something like that. But we will think about that later. Now let's focus on the short-term goal rather than thinking about the very long term. So first things we need to do is whenever we try to register a queue, let me just think about this. Before setting up the lock, we will do something like, if the queue does not exist, if the queue is nil, the user passed nil as a parameter, we will simply say return errors.new. Instead of also I'm thinking, instead of writing every time errors.new and errors.that, I can define errors in a separate variable which can be exported to, so that will make other files also use similar errors. So let me first think about this. What should we call this error? Since the user sent nil, we can just name it error nil queue, and it will be errors dot new, which will be something like queue is nil, something like that. And we can use this now instead of writing every time this. Next error we will need is, before error, let's define what other functionalities we need. The name, the queue to be registered does have a name, so we will do what we'll do is we'll take the name of the queue and trim it down so that we can check if the user just sent spaces, something like that, to validate the queue name. So let me do the code. Name equals to string dot strings dot trim spaces. We have trim space function. It will trim the spaces around the name, queue dot name, and that's all we need. So now we have a name variable which is validated and does not have spaces around it. Now we will check if name equals empty. If name is empty, we will return an error. Uh, most of you, if anyone is wondering why didn't I stream last day, the thing was I was reading about Redis and I read a lot about Redis. I'll share my knowledge today when I'll write the Q based code. For today, we'll do we'll just write Q based code and the Q manager code. This week is going to be, this phase is going to be somewhat pretty important. So we need to do it with, I need to do it with care and precision. Sorry. Let me next write the name. Cannot be empty. Something error like this. If there is empty QName, and we will return error empty QName. Next we'll lock and defer the unlock. That's not going to change. But here instead of passing q.name, we'll just pass the name, which is the validated name. And instead of this, we can just cut it out and have it here like Q already exists. What was there? Oh, sorry. Yeah, Q already exists. So I'll name it error Q already exists. I want the errors to be much more easy to understand, even if I see error like this, but I'll see error like this. The user of these errors should understand by the name what the error suggests. That's why I'm going for this much beginning. Okay, we will return error Q already exists. And then we will do what is, we will take the Q from here and change the parameter to name. And here we will set the part. I told you if if there is no default queue, we will set the first registered queue to be the default queue. So what I'll do is I'll set if default queue name dot default queue name equals empty string. Then we will do is queue manager dot default queue name equals to name, and that's it. I think this much is good for register. Next we need some changes in get functions too. So first we'll do is we'll take the name and again we will validate the name like we did last time, strings dot trim space. I'll just copy the code. Control V, Control C, and here we will paste the code, and that will work fine. Here it's taking q.name. We'll pass here just name, and here we will do something like this, and this will be q name equals this error, and it also passes the q, so we'll pass f nil. This works fine. First we will check for name, then we will do the lock, and then instead of this we will use error q not found, something like that. So let me define the error. Let's copy the value. Here q not queue not found or queue not, yeah, queue not found was done. Alright, so these are our errors defined. Let me just pass the queue not found error, queue not found. So the thing with get is also done. Next we'll do a thing which will be set a default queue by the name, so that user can change the default queue. The default queue is nothing but the queue that will work for this type of jobs. The job we wrote last time, which was taking the default as a name, but now we can simply let me first write the code, then I'll tell you what I mean by this. So first I'll write func that will be on queue manager, queue man, that's it, start queue manager. If I use AI, this part is pretty much as easy as it can be, because I'm doing repetitive tasks. There's nothing new, I guess, here. New string, what it will give us is error. So this function will be used to set a queue to be the default queue. Again, we'll do this. We'll see. We'll check, and we'll throw this error empty queue name, and then what we'll do is we'll lock queue-manager.mu.lock, and we'll defer the unlock. mu.unlock. Alright, next we'll check if the queue exists or not. Queue with the given name exists or not. You can simply copy the function from here. If not exists, yeah, this will work fine. And looking at this, I can also do something like this. If not exists, I'll do something like we don't need the queue for this part. We'll just use this, and we'll throw error. Yeah, we'll throw the error. So in this statement, I'm checking that if the queue exists. If the queue doesn't exist, we'll throw the error queue not found. And lastly, what we'll do is, if queue exists and the queue name is not empty, we'll do what we were here for. Queue manager.default queue name equals to the name we trimmed, and at the end we will return nil error. That's all we need to do in this function. Next function we will do is get the default queue. I mean, work with the default queue. In this example, in this usage of our create job, we had to get a queue named default, but in this part, what we'll do is we'll provide the user the default queue. Let me just give you the code, then I think you can understand more what I'm trying to say. So what I'll do is QUEUE. My spellings are pretty bad, so that's why I always check that. Queue manager, that will give us default, not default, this one, default. The access to default queue will be given by this function, which will take nothing as a parameter, and will give out a queue and an error. So what we'll do here is we'll have a lock. Since we are reading, we will use rlock and defer queue manager queue man mu.runlock. Yep. Next we'll do is check if the default queue is not set yet. I mean the default queue name is not set. So what I'll do is if queue manager dot default queue name equals to empty. If the name is empty, I'll return nil comma default queue. This means default queue has not been set yet. So what will create a new error? And let me close this window. This will work fine. Error queue. Default queue is not set. Default queue not set equals to errors dot new default queue is not set yet. Something like that will work. I mean D should be smaller. Default queue is not set. So I'll use this error here. Okay. And what's this? Why this is something like this shouldn't be like this. This will be like this. And I'll throw the error if default queue is not set. Next thing I'll do is here is I'll return yep, this is what I need. Next I'll check if the queue exists or not. The queue named with the default queue exists or not. If it doesn't exist, we have to throw an error. So what I'll do is take queue comma exists from queue manager dot queues with the key as queue manager dot default queue name. If a key if a value exists with this key, then it's okay. If it doesn't exist, we'll do is if not exists, we'll return nil and error queue not found, something like that. Yeah. And at the end, if everything works fine, we'll return queue and a nil. Now there can be situations when the user needs to know what's the default queue name currently. So I'll create a small function for that too. I'm creating these functions so that in the later phase I can expose APIs directly based on these functions. So I'll write a default name. It will give us a default name which will be a string. And should it give an error? I don't think so. It should give an error string. If default queue name is empty, it will return empty, and yeah, it doesn't need an error. Let me copy this one. I don't feel like it. Or return. I'll return the queue manager dot default queue name. That's all I need from here. Sometimes the user also may need to know what are the queues present even in our queue manager currently. So what I'll do is create a function that lists all the queues in the queue manager. List names, I guess, because it will work on queue manager, so that's fine. It will give us a string slice. And what should it throw an error? It's just retrieving names, so error is not retrieving. So let's just work with this. I'll do this. I'll defer the unlock. I'll check names. What I'll do here is make a slice of string. Slice of string. Okay. and then I'll initiate a 0 value, and then the length will be queue manager dot queues. So what I'll use a loop here for name in range of names. Should it work? I should use queues here, and range in queues. I'll do what is. I'll make names equal to append names with the name. Yep, that works fine. For a quick touch, what I can do is sort the strings to go in alphabetical order, and I'll return names. So I think the queue manager part is done. We have written set default queue function, and function for listing the names. Everything looks good to me. Let's move on to the main part. Before going there, let me tell you what we used as a sorting basis in our memory queue. In our memory queue, first we sorted based on run after time. If the run after time for each of the job was equal, what we did was sort based on priority. If that also was equal, we sort based on created at, and at last we sort based on the job ID. I'm telling you this because this will come in handy once I try to give you the context about how we are sorting in Redis. Also, give me a second, I have a call to attend. I'll be back in like a minute or two. जी पढ़ रहा था। हाँ जी हाँ जी जी ठीक है sorry, there was an important call, so let's continue the part. I was telling how I was sorting. In this part I was using heap, the heap implementation of the Golang. But now in Redis, what we will use is sorted sets. For that, let me create a diagram to tell you how the things will go. So what we are going to do is we will create a sorted set. A sorted set in Redis is a type of set which sorts the things like based on a key, not a key, I can say based on score. Now the score should be like, in our case I'll define the score as lower run after means higher score. If there is lower run after, then this will be higher score. But now the question arises, how will we handle the three other properties like priority, based on priority, based on created at, and based on our ID, because they are the tiebreakers in our situation. So in Redis, it only takes one argument to create a score. So what I'll do is I'll create a h set, which will be a hash set. So I'll create a hash which will store the three things, and I'll write logic around that. I mean if score of two jobs is same, based on the hash, I'll sort the uh, I'll try to sort the jobs which will come first. Before moving on, let me tell you an important part. Redis uses lexicographical sort. Lexicographical sort. If score sort is similar, let me just similar. Spelling should be different. Uh, Lexicographical sort if score sort is similar on members. So we can create members here. The members will be our hash, a hash containing the information about these. But to do lexicographical sort, we will need to use some tricks like bit manipulation, because if I try to do something like 9 with and 10, if I try to compare these lexicographically, 10 will come first, but in real world, if I compare two numbers 9 and 10, 9 should come first. For that we will use some bit manipulations. I'll try to simplify things while I code, and try to draw some diagrams if needed, if I think they are needed. So let me just start writing the code. First we'll do is create a redis.go file. Okay. So we will need Redis implementation here. So what I'll do is get Redis. Current version I have checked on GitHub is version 9. So I'll just paste it here. I'll get the package, and then I'll do go mod vendor. It's been added, I think. I don't think so. Go mod vendor. It didn't come. Go get go mod vendor. Go mod ID. So there's the thing I remember. We have to use the package first. Then only after we can get the package, or who will remove the package without knowing we want to use the package. So what I'll do is import. Let me first name the package. The package is Q. Import. I'll import the same and github.com. Yep. And now I'll do is go get github.com/this. It will add. Next I'll do go mod ID, and lastly I'll do is go mod vendor. Now everything will work fine. I think it should work fine. github.com imported as Redis and not used. Yep, it has been imported. I don't yeah. Now the vendor folder is also added. So let's start working. Forget about the error for now. First thing we need to do here is define the prefix for our key in Redis, because as you know, Redis is a key value pair. So how can we differentiate whether the key is for a queue or for a job? So what I particularly use is create prefixes for my keys. Redis queue key prefix, something like that. it will be sorry, it will be the name of the project I'm working on, GoTaskQ, and this will be a prefix. This will tell us that the key stored is for a queue in our GoTaskQ project. Okay, I think this will work for now. Next, I have to define a struct for our Redis queue. Let's define a struct. Type struct type Redis queue. Here we will tackle the first difference from our in-memory queue. In the in-memory queue, what we relied on was mutex. But the mutex is only process-based. So, and Redis is a universal store. Multiple Go threads, Go routines can target the Redis system. So what we'll need here is scripting. So I am thinking of using Lua because I read in the documentation of Go Redis we can use Lua scripting, and since Redis is single threaded, it will use global mutex to run only one script at a time. That will ensure that the concurrency remains atomic. It means the data cannot be manipulated by two Go routines at the same time. Atomicity remains our main priority here. So let's define the struct. There should be a queue name that will be a string, a key for the queue name, a key for the queue, and a client. Client will be Redis dot universal client. So universal client works as something like a client which automatically resolves itself. Instead of choosing between different clients, Redis will check the arguments passed, and based on the arguments it will assign us the best client which we will need. So what I'll need first is to define a new Redis queue. I need a function to define a new Redis queue. What I'll do is func new Redis queue, which will be simply taking argument of names, which will be string, and a client. Client will be Redis dot, which will be type of Redis dot universal client, and then we'll do what it will give us back. I forgot. So it will give us a Redis queue, a pointer to our Redis queue, and error if any occurs in the process. So let's start. So first we'll do is trim the queue name, validate the name, the simple procedure. Queue name equals to strings dot trim space. We'll use trim space, and we will trim the name. Let me write about this. I'll trim the name and check name. Trim the name. If queue name dot equals to empty, we will use the pre-made error, which was queue error empty queue name. That's why I created errors as that, because these errors might be used at many places. So instead of writing every time a new errors.new, we can simply use the variable instead of those error.new and that. Next, We will check if the client passed is real, if the client passed is nil. If it is nil, we'll throw an error, because sometimes the user, we can't rely on the user to enter the safe input. So we will do is define error. We have to define an error here, just like we did there. Let me define an error where, which will be error Redis client nil errors. Should I use errors.new? Yeah. One thing I'm particularly interested in finding is what is the difference between errors.new and fmt.errors, error, something like that. I need to know about this. After the stream I will check, and then only my internal voice will stop. Let's do something. Error Redis client nil. Yep. Now the next thing we need to do is we need to return the Redis queue. If everything is fine, we will return the Redis queue, which takes a name, which is queue name. It takes a key, which is so for this our key should be something like the prefix plus our queue name and the status of the queue. Yep. So I'll do something like fmt.sprintf to format %s %s and pending. So the first %s will be our Redis queue key prefix, and the second %f will be our queue name. Yep. So it will be something like if a queue is named like a logger queue, so it will be GoTaskQ queue logger queue pending in our database, in our Redis. Pending means the queue is still pending, it's not being active, it's not being used. I mean, it's in pending state. It means the queue is not giving us a job currently, something like that. And next we'll need is a client, which will be simply our client. Or what's the issue? And I told it will throw an error, so we'll return nil. Yep, everything looks good. Everything looks good. But now, when I'm thinking about writing enqueue, there's one issue here, that to enqueue a queue, we will not enqueue a queue based only on the score. We also need the members, which are hash, hash, Redis hash, something like that, hash in Redis. So what I'll do here is I'll define a payload to go with the score. So there will be a payload with the score, which will be a hash. Based on the hash, sorting will go if the score sorting fails. Okay, so for that I'll need a payload key, something like that, payload key. which will be a string, and I have to define a prefix for that too. Redis Redis-Q payload key or payload key. Instead of defining a prefix, what I'll define is a suffix. Redis-Q Q payload key suffix, which will be something like payloads. Payloads. Okay, we'll use this in this payload key. Now to write it here, payload key is equal to fmt.sprintf. What we will use here is this part, and lastly, instead of pending, we will use payloads. That will define that the thing is for the queue, let's say named logger, and that's the payload for a logger. %s, %s. It will be Redis Q key prefix, then it will be name, then lastly it will be Redis Q payload prefix. Instead of name, we have trimmed the name to Q name. So this is how it will look. A queue, for example, should I write an example? I don't think so. It's straightforward. So no need to document it much further. Thinking about documentation, I'll write documentation once I write major function. So next we will do is create the function from our interfaces. This is the function we will create. Func will be control V. It will work on our Redis-Q. Let's name it Redis-Q star Redis-Q. Context, let's import the context package, let's import the job package, and everything works fine. Let's format this out and let's write its implementation. So how NQ will work is, first we will write a helper function like we wrote here. If we wrote here, did we wrote the helper function here? Last time I was writing a helper function. Oh, it didn't use context, so I never wrote the helper function. Let me get the helper function from here. Store.go. Validate context. It's a helper function which will be used inside. I like to write my helper functions above everything. Okay, and I don't care if the helper function gets repeated, because it's a small function that just validates if the context is correct or not. So what I'll do first is I'll check for the context. If error in validate context ctx will do on error error not equal to nil, sorry, nil. What we'll do is we'll just return the error, which will be context error defined here, something like this. Context is null. I think do I need to update the helper function? I don't think so. This helper function works great. according to me, yep, this works again. Great, according to me. So what we'll do is we'll check, instead of writing job, we'll use J. Okay. Because the issue is that the job sometimes gives us problem. Like last time, if anyone has watched my stream where I debugged the issue, so I always now write it as J. If J is equal to nil, if J is nil, what we will do is we'll return errors dot new job is nil. Let me think, do I need this error again somewhere? Let me think. In this package I don't need this error again somewhere else. If I need this, I'll change the error to be a variable, but for now, according to my thinking, I don't need this error. What I'll do, I'll define the time, which will be time.now. Just like we did in the enqueue in our previous memory version. If I can show you, yeah, here. So enqueue didn't need such yeah, here we use time.now, but instead of using here, I'm just defining it here. I can use that like that, but this works fine for now. Okay, so what we'll do is, if job.run after, a simple statement, if run after is 0, it means run after is not set. We will set the run after, g.run after. Of the stream, I'll write the documentations. That will be much better. I'll use AI there, simply saying, so that the stream is not bothered by the documentation. G.delay. I'll write small comments if needed, but I don't think it's needed here. So what I'm doing is, if j.run after is 0, it means it is not set. We'll set the j.run after to be created at plus the delay. That's simple as it. And next we'll check if j.run after dot before, it means it has to run before now. Then we will update the j.run after to be now. This will make the job run now, instead of we losing the context for the job. This is my interpretation. This is my, what we can say is, this is my way of handling the jobs that have been already been like this. I am not able to give you the words, but I think you can understand by my expression what I'm going to say. So what we will do is, I told you that we will define a members hash. Now is the part we will define that member, which will be Redis-backed dot. We need a function here. We will need a helper function here. So the helper function will just encode our priority and created at and all that on the basis of lexicographical usage. So this is the part where I think uh, I had to means study for about half an hour to understand what is going on. I'll try to explain the part with ease, but if you can't understand, just comment out. I'll try to answer to each and every comment if any occurs. Let's. So what I'll do is I'll define a field width. This is a pattern. So let me give you a pattern. Redis sortable field width equals 20. So now you might be wondering, why 20? Why arbitrary number like 20? So 20 is the exact number of digits in unsigned integer of 64 bits. So I'll be using unsigned integer of 64 bits to pad zeros into the digits. Let me give you an example. Let me just write an example, then you can understand much better. Let me give you an example with, let's say I have 8 bits. 0 0 0 0 0 0 0 0. This is our 3 3 6. Yeah, this is 8. So this is a 8-bit number. What I'll do is I'll XOR the number with 0 1 1 1 1 1 1 1 1 1. Sorry, I'll write shift 1 7 times. In our case, we will do this 63 times because we will be using int 64. So here in the case of int 8, we will use unsigned integer 8. We will use left shift 7 times. So whenever, let's say, a number like -1. So what is the interpretation of -1 in binary? It's 1 1 1 1 1 2 3 4 5 6 7 8. So it's 1 1 1 1 1 1 1 1, something like that. 1 2 3 4 5 6 7 8. Yeah. So what will end up happening is it will convert -1 into a number which lies between the range of 0 0 0 0 0 to something like 1 1 1 1 1 1 1 in unsigned integer. So this bit will not represent, the last bit will not represent sign, but will represent a number. How can I explain this to you? This is the case. Let's give you an example. When I XOR with the let's say XOR with our 0 1 1 1 1, that's 4 5 6 7 8, then the answer will come out to be 1 XOR 1 is 0, because XOR works like this 1 2 3 4 5 6 7 8. So what will this number represent in binary? This number will represent our equals to 2 4 6 8 16 32 64. 2 will be 1 2 4 6 8 16 32 64. I'm missing one bit, I guess. 3 3 6 7 8. It shouldn't be like this, but okay, no one cares about that. It will be like 64. So -1 when converted to our intended range will convert into 64. So 64, and let's give an example of minus 10, minus 2. Minus 2 equals to, it will be minus 2. The value of minus 2 is, if I remember correctly, this should be 1 1 1. That's the 2 complement. It's take the 2 complement. I don't remember the value of minus 1 and minus 2. Let's go with the example of 5. It will be 0 0 0 0 0. That's 3 4 5 6. 1 2 3 4 5 6 7 and 8. There will be 1 or 1. This will be 5 when I OR with our digit, which is XOR with our digit, which is 0 1 1 4 5 6 7 8. It will come out to be a bigger number than minus 1, which we intended. But in if we went through a lexicographical order, this case will work indefinitely, but the case of 9 and 10 will not work. So I'll give you some example in there, like 5 and 10 I'll give you example, but for now I'll just write the answer to this, which will be 1 1 1 1. The last 3 digits will be 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So it will be 0, and here it will be 0. That will represent a bigger number. That will be like my binary is not very good, but I can assure that once you go through this transformation, you can understand. Or if you can't understand, I'll link article which will tell you how this method works. I'm not good at explaining this type of stuff, sorry. So if anyone can't understand, just comment it out, even though no one watches my stream, no problem. Okay, next we'll have a variable Redis sortable signed bit, which I just told in the diagram. In the case of uint 64, in the case of in the case of uint 8, it was 7 times left shifting, but in the case of 64, we'll do it 63 times. So I have a sortable sign bit which will help in XORing. So next I'll need to define 2 simple functions which will help us in sorting in increasing order and in decreasing order. Okay, so first I'll do in increasing order. First, encode ascending order, something like that will be ascending order or ascending int 64, which we can tell by the function that it will be used to convert int 64 into a ascending order type uint 64. String will generate a string, return fmt.sprintf. So here we will use something like %0 $d. What this means is the first argument we passed will be the number of zeros the string will have. So it will have 20 zeros, and then we'll do here is uh, fill this with u int, which should be u int 64. It will take v. So it is converting the integer int 64 into u int 64, and then we OR with the Redis sortable sign bit. So this will give us a string based sorting in ascending order. Next we will define a function that will do this in descending order. That will be similar to this one. Just one thing, we will be using a bitwise not operation there. So let me just encode descending in 64. If anyone visits my repo after a day or so, there will be documentation here for these functions. So if you can't understand from my wording, you can simply see the documentation. That will be much more helpful because I will be more able to express myself. Redis sortable filled with. So it will fill the string with 20 zeros, and then we'll do the upper part we did, and then do a bitwise not on this, and that's all we need. Okay, next, based on these functions, we'll need a function that will create a member for the job. So member, I told you, will be a hash. So a hash is just a string which will pass along with our Q score. So let me just create a function on Redis-q star Redis-q, which will be member for job. It will give us a job. It will take a job and give us a string, a member string. Job.job, and given a string, a member string will be given. So it will return fmt.sprintf. What we'll do is have a %s pipe, %s pipe, %s. So first it will sort based on, I told you it will sort firstly based on run after, which will work based on the score. After that it works based on highest priority, whichever one has the highest priority. So we will use encode descending in 64 because the highest priority one will come above the others. So encode descending in 64 will do in 64, and it will take job.priority. Next we will need is encode based on ascending in 64, means the smaller created time will be used first, created at, and we will use Unix Nano. You can see here it returns the number of nanoseconds elapsed since the time, like that. Okay, since the time the Unix epoch was defined. And lastly we will do j.id and the ID is time based, so it's already lexicographically um, sorted, so there's no issue there. So these are our three functions which we'll be using. Let me cut these functions and write them at the top. Should I write them? I like to write my helper functions at the top. Let me just define something like this. Equal to, I like this format, helper functions. Yeah, I was so much accurate. Wow. This is a part of helper functions. This is our main functions. Main functions of by one. And this will be like this. So this can help us determine where the helper functions are and where the main functions start. Okay, we'll use redis-q.member for key now, and we'll pass the job. It will give us a member string. Now the next thing we will do here is convert the member string to a hash. Before converting to a hash, we need to convert the member string to JSON. So what we will do is use json.marshall. So it will give us a payload, error, json.marshall, and it will give us a byte array. We will just use that byte array. Before going with the byte array, I have to check if the Marshall given to us was a nil. If error, return fmt.errorf Marshall job for Q, which will be a %w and our error. Okay, if there's no error, what we'll do is we will use a Redis function, which is Redis Go function mainly, which is tx pipeline, which will pipeline our multiple Redis requests into a transaction, so that even if one fails, the whole transaction fails and it returns an error. So let me just write the implementation. redis-q dot client dot tx pipeline. Okay, what it takes, as we can see, it takes a context which we passed from above, context, and a function. The function signature is given to us. The function takes a Redis pipeliner and gives us an error. So let me write the function body and define and tell you what it means. Func. Yep, this will work. We'll name it pipe. For clarity, it's a Redis pipeliner. Each pipeline is a request. The difference between TX pipeline and normal pipeline is the pipeline can fail one or two tasks, but it will basically focus on speed rather than atomicity. But we need atomicity, so I'm using TX pipeline, which converts it into a transaction and make sure that atomicity is preserved. So what I'll do is pipe.h_set. So I'm creating a hash set. Means I'm creating a hash and setting its value. Redis-q. Sorry. What are the? It needs a context and a key. So it will be Redis-q dot payload key. Okay. We create a hash based on the payload key and the member, and yep, so it will take a value and interfaces. Member is the name of the name, but I can give you is that it will create a hash. Next we'll do is create a sorted set, add the value to a sorted set. It will again take a context and redis-q dot key, and lastly it will take a redis dot z. So z defines the struct which is score and a member. So member we have defined here. So we will just tell Redis what are the member of our sorted set entity mainly. So we are adding an entity to our sorted set. So we'll do score. Score will be based on float 64 j dot run after dot unix, and I'll use unix millisecond here. So I'll use millisecond precision, and based on this Redis will sort the set, and we will retrieve value based on this setting. So member will be our member. This will be the member string, and the payload is also there which we have sent, and everything looks good to me. Yep, it returns an error, so we have to also think about this. Return nil for now, and here it might fail. The TX pipeline might fail. So what we can do is if this comma error equals to this. So TX pipeline gives us a this and a error. We don't need this thing. I don't even know what is this, but we are focusing on error, so we will just focus on that one. So what I'll do is we defined error above. Yeah, I have defined error above, so let's give it name something like this. Okay, if there's no error, so I don't need if here, I need error. I need to retrieve the value. If error not equals to nil, what we will do is return an error saying that the transaction failed, something like that. Return fmt.errorf nq. I don't again wrong with the spelling. nq Redis transaction failed, and error which will be %w error, and that's all. And lastly we will return nil. If everything works fine, we'll return nil. This can be difficult to understand in one go, but what it's giving us is a sorted set with a member which has a hash based on our encodings. Simple terms. Now the difficult part here is defining a DQ. So for defining a DQ, what I will need here is where the squiggly. Here is a squiggly. Why is there a squiggly here? Missing here. Oh, sorry. That's why there was a squiggly. Yep. Now everything is okay. So we will need a Lua script here. Lua script. I should write a Lua script here. Lua is highly embeddable language if you don't know. So it can embed mostly to anything. Lua script. Lua script for DQ operation. Okay, here there will be a Lua script for our DQ operation. So let me define a Lua script. Okay, since the Lua script is different than the language, I'll also define documentation, a small set of documentation here. So let's define the name of the Lua script, which will be DQ ready job, something like that. DQ ready Lua. That looks cool to me. Okay, so it will be a string literal, which is a type of Lua script. Here we will write all our Lua script. Before going further, let me write some documentation regarding this. So DQ ready Lua script, what it will do is, we'll see, let me control V. It will do is, it will automatically, atomically, what I'm saying, atomically return one job, one ready job, and DQ, and remove it from the queue. So this is our Lua scripting part, so that only one goroutine can work with the Redis part at one time, because Lua script will be blocking as the Redis is single threaded, so there should be atomicity. So let me define a return shape. The zero, if the return is 0, it means the queue is empty. Okay, if the return is 1, why is there like this? If the return is 1, it means there are no jobs ready. And if the return is 2 with a payload, which will be a job JSON string. Okay, this particular thing means the operation completed successfully. So this is our return shape. So let me define the Lua script now. So we'll take local now in milliseconds equals to number I'm not good with Lua that much, but I can code some. But so it will take argv1. So we'll pass an argument with the current time, and it will convert that current time millisecond into number. This will be used to determine the score and all that. Okay, so what we'll do is we'll loop through the process, something like local items equals to firstly let me write the code, then I will give you what this means. Redis.call. So Redis.call will call a function which will be zRange in Redis. So what zRange does is it retrieves the values from a particular range based on the keys. So I'll give a keys 1. Okay, and now I'll do what is, I'll pass 0 and a 0 and with scores. So this will give us a list of items from 0 to 0. That means it will give us one item with score. Okay, so what we'll do is if number of items, to check number of items in Lua we use hashtag equals to 0. It uses if then statement, if then and end. Then what we'll do is then we'll return 0, and lastly it ends. Also the loop has to end here. Okay, so Lua scripting is highly embeddable. If anyone is interested, I will particularly say go for it. It's pretty good at scripting. Even in embedded systems, sometimes I have seen Lua being used. So we will define the member. We will get the members from items 1. Now you might be wondering what items 0 to. So Lua, in Lua, the arrays or the slices, as you say in Go, are 1 indexed instead of 0 index. So in Redis first gives us the member and then it gives us the score. So we get the member, which is items 1, and local score. I'm using local score. Yeah, also local means the variable is local to the scope. 2 numbers. Okay, items 2. So we will convert the score to numbers, and then we will check if the score is greater than now ms, which we defined above here. If the score is greater than now ms, that means the job is not ready yet. Then we'll return 1. It means no job is ready yet because the top job is not ready yet, and then it will end something like this. And next what we will do is have a payload. Get the payload. Local payload equals to, again we will call Redis and get the set value, hash value. Redis.call, again calling, and we'll do is hget. Here we will use keys 2. So once I write the function, you will understand what keys 1 and keys 2 means. But in simple terms, I'll pass the keys 1 and keys 2 in my Lua call when I will call this script. So I'll tell you then what it means. Member. So based on keys 2, I want to get the member. So Redis will give us the member, that will be our payload. Now if we have a payload, then what we'll do? Then we will call Redis again and we'll remove the entry of the what do you mean sorted set, which has keys 1 and has member this, and then we will remove the hash, which will be removed using hdel. So these functions, I had to read through them in the documentation of Redis. The Redis documentation is pretty good if you want to know about these functions. Keys 2 and member. Redis.call, this will work fine, and then we'll return 2, payload. And then we'll end the function here. And lastly, even if there is no payload, what we will do is we'll remove the entry of the sorted set. This will help us. This small script will help us attain atomicity. This was a dotting part, to be honest. So now the most important function, I'll write it down, and then there will be 1 or 2 functions, and then I'll end today's stream. DQ is the most important function currently. It's already been 1.5 hours. I am going to feed. Let me write the function for DQ, then I'll end the stream after writing some small functions. Redis-q, which will be a Redis-q BQ. What was the... Let me just copy this so that I don't mess up the interface. I'll just name the variable J, and I think this works fine. Yeah. First thing we need to do is validate the context as we did earlier. If the context is wrong, it will give us nil as a job and an error. Now is the time where we will use the Lua script. So the package we are using gives us redis-q.client.eval, which will take a script and evaluate it. So let me just write it in text. dq Lua, which is a script, and it will take slice of keys. Here we will define the keys. So it will be a string slice, which will be it will have 2 values, so I don't need to define it differently. I'll just make the formatting better so that readability increases. So what it will do is it will use Redis-q dot key and Redis-q dot payload. So now you can understand that the key one here was Redis-q key, and key two was Redis-q dot payload key. Okay, so this is good. Next, one thing we need is an argument. It takes arguments which is any type. So what will give the argument as time dot now dot milli Unix milli. So now the argument, the Lua script can take the argument from here to number and get the now and this. So this can give us a dot result. So it will give us an interface which will be of type any, s comma error if any, and we'll use error if error nil, will return nil comma fmt dot error f tq redis eval failed, something like that. %w and lastly the error. Okay. Next part we'll do is we will check for the parts in the interface. So we'll create we'll make the, let me just show you. We'll create parts comma okay will be the approach equals to res dot, we will type cast it into a any we will typecast it to any slice, a slice of any type. So if this is not okay, then we will return error. If not okay, or there can be a case when length of parts equals to 0. If length of parts, it means there's nothing in the parts interface, we will just return nil comma fmt dot error f, which will be I don't need fmt currently. I'll use errors dot new, which will give us unexpected response, something like that. Expected the Redis queue response. Okay, so what we'll need is we need to check the code which our script sent. So it has parts like this. Part 1 is 0, 1, 2 and something like it, and there's part 2. So part 2 will be our payload we'll get. So let me just write that down, what I mean by that. So we'll check the code which was sent, and we need to convert this to int64, since we are working with int64. So I need a helper function to do so. let me just write a helper function. I need a helper function because the type of the response can be string, int, or int64. Based on that, we need just int64 for our work. So let me just write it down on Redis interface, whichever interface we get, to int64. 64. It will take v of type any, value of type any, and gives us a int64 and an error. And let me wrap them around. Yes, that's okay. So we will write a switch statement here, switch case based on val, which is v dot type. Based on the type, we can check case int64. If the type is int64, will return the val, comma, nil. Oh, okay. Case, if it is int, normal int instead of int64, we will typecast return int64 val, comma, nil. Okay, lastly we have to check string case string. If the type is string, we will parse it into an int of base 10. Let me do so. str string convert dot string convert dot what I need is parsing. So base, it will take a string which will have a value, and base, which is base 10, and a bit size of 64 bits. It will convert it into a 64-bit integer. If error not null, will return 0, comma, error. If error is not null, we will return 0, comma, error. Yeah. Return first, comma, nil if there is no error. And lastly, we'll have a default case. If there is any other type, we'll just say unsupported type. Return 0, comma, errors. Sorry. Unsupported type. Percent T. Well, we don't need val, we need v, because val is already a type. So I think everything is looking good here. We'll use this function to convert the code from a Redis interface to our own interface, to int64. So let me write this down. My throat is aching now from talking through all this. I need to rest. Redis-q. Sorry, what was the Redis interface to int64? which will pass parts 0, if there's if conversion error is not equal to nil. If conversion error is not equal to nil, what we'll do is we'll return nil comma ffg dot error f invalid Redis-backed status code. And the error associated with it, and that will be ERR. Sorry, it shouldn't be ERR, it should be convert error. And I think this will work fine. Next, based on the code, we'll write a small switch statement. Switch based on code. If the case is 0, if the case can be 1, if the case is 2, that's all our cases, and a default case. So thinking about case 0, what will case 0 do? It will just tell us that the queue is empty. So it will give us nil errors dot new queue is empty. Next we'll do is if the status code is 1, we'll return nil errors dot new no jobs ready. Okay, and lastly, if the case is 2, we have to check length of parts first. If length of parts is less than 2, it means there is corruption in data. So we will do is return nil and then errors dot new, which will be invalid job payload, something like that. Invalid job payload type, that is DQ response. I want the errors to be as much explicit as they can be, because these are the things which will help us later in debugging. And what I'm writing here is, sorry, it should be missing job payload. What I'm doing here is type in Redis-backed response. Yep. Now next thing we will do is check raw bytes. Again, we'll need a helper function here. Okay, before telling you why we need a helper function, let me just tell you what I mean by raw bytes. ERR. What I am going to do is convert the Redis interface into a string, because the parts one can be string or it can be other forms like a byte array. So we have to handle those cases. So I'll create a helper function. The helper function will be, let me write a helper function. Func Redis string value. It will take a v value of type any, and it will give us a string and an error. Switch case will be there, which will take a value, and again v dot type, just like we did with the int64 conversion. But here our cases will be string. If the case is string, we will just return val, comma. What's the issue? Found simple statement. Oh, I forgot about this. Yeah, it will return val, comma, nil error. If the case is a byte array, byte slice, byte array, as we say say normally in networking, a byte array, then we will do string val nil. Why there is Redis nil popping up every now and then? We'll have a default case which will just throw an error and return an empty string with an error, unsupported type, just like the above. I can copy that, I can paste that here, and this function is done. It will be used here. Let's use this here. Redis string value of type v, which will be our parts 2. We need the string value of our parts 2 parts 1, because Go uses zero-based indexing. I was confused in between low and go for second, sorry. So Go uses zero-based indexing, so it will be parts 1. So what I'll do is, if there's error, I'll return nil, and the error should be like fmg dot error f invalid job payload. Just like this. And I'll have a %w, which will be our error, which can clarify what was wrong. Now we will define a variable output, which will be of type job. Why is there issue? Yeah, let's do it. Output will be of type is that job included? Unreachable code. Oh, that's why my everything was failing, right? Output is a type of job, and job is a, yeah, now everything looks good. So what will output is defined here. So what we'll do is we'll marshal the output based on our raw bytes. Let me tell you how it will work. If error json.marshal json.unmarshal. Now this time we will unmarshal the JSON, and it will take a byte array, which will be converted using the raw string value and it will take interface, that's our output interface, and it will take this so that it writes an output, and if error occurs, error not equal nil, we will do is return nil errors dot fmt dot errorf as we are doing, and unmarshal dq job field with error is error. Okay, so now error is also defined here. Everything looks good to me personally, yeah. And lastly, what will return if everything succeeds? We will return percent output and nil as error if there's no error. And lastly, the default function will work right. It will return nil, it means no job is there, and error, which will say unknown Redis DQ status code. And the error, which will be instead of returning the error, we will return the code. Differently, I think this is enough. Next thing, and the last two things remaining are the length and the name. Let me write those small functions, they don't need much context, so let me just write them faster as I can be. Func Redis-q star Redis-q length, it will return int, remember, and let's create a context for this and a cancel function for this. If we can't get the length in 2 seconds, we will cancel it. Context dot with cancel, or with timeout, we'll use with timeout. We'll set a timeout for 2 seconds. Context dot background and a timeout for 2 seconds. Time dot 2 into time dot second. So what we will do next is we will defer the cancel at the end of the function, and lastly we'll give out the count and an error if an error occurs. So we'll do is Redis-q dot client dot z card, which gives us the count of the current Redis hash set. Redis-q dot key q dot key and a result to map this up. So I'll get a count and an error. If error is not nil, every time like that, we'll do is return 0, and lastly we'll return the count in int count. And for the last function of the video, what we'll do is func Redis-q star Redis-q. It will give us the name of the Redis-q, and it will be a string return Redis-backed dot name. I think this is enough for today, and I have mostly covered how the queue will work, like how the sorting will happen, also the NQ and the DQ operations. I have gone through them thoroughly, and the Lua script I have told about it. So let's meet tomorrow.